for this first inaugural lunch. But yeah, if you're interested in speaking at one of these events in the future, do reach out to me. You can either join the Data Lakehouse Hub Slack community or the Dremio Slack community. I'm on both. Then that would be at developer.dremio.com. In either place, great place to meet other people who are learning about the Data Lakehouse and things. And yeah, here we go. So let me move on to the next slide. So we're going to be talking about architecting Iceberg v4, in the sense basically learning about how the community is coming together to decide what the future of Apache Iceberg is going to look like. So this will be a presentation that's going to assume that you're familiar with Apache Iceberg, the Data Lakehouse table format that allows you to have tables that run essentially off your storage without it necessarily being part of sort of like a bundled database or data warehouse system. It gives you asset guarantees, time travel, interoperability, all sorts of really great things. And Apache Iceberg has become the default when it comes to data lakehouses. But of course, as you become more and more used, people try to use you in more and more ways and discover, things that are not necessarily perfect. And that's why you have different versions of Iceberg. You're constantly trying to architect it to something even better than what it was. So while Iceberg currently already serves many use cases very well, the things things like very having sort of like high amount of very frequent transactions and low latency streaming and whatnot, these are going to be kind of things where there's still sort of work that can be done. Okay, and just being able to just traverse the metadata tree faster, being able to commit a transaction faster, and things like this. And this is where a lot of the work in designing Iceberg v4 is coming to. But again, before we get deeper into the presentation, I do work for a company called by the name of Dremio. Dremio is the agentic lakehouse platform. And essentially, you can think of Dremio as sort of three layers. There's the federated query engine, where you can run SQL queries across data lakes, databases, data warehouse, and lakehouse catalogs. So essentially, you can unify all your data in one place. The idea is you can get a lot of the benefit of basically a data platform without having to move your data on day one. You can get the platform of being able to have governed access across all your data that is AI enabled on day one with your data where it is. Now, of course, over time, you are going to want an Iceberg Lakehouse. Reason being is that one, you save a lot of money on the storage of data, you reduce your a lot of duplicative ETL that might build up over time, moving it into different data warehouses and things like that. But on top of it, you get interoperability, where basically with Apache Iceberg tables, pretty much any tool can talk to those tables. And Dremio has a built-in catalog, so that way you can govern those tables. You can connect it. It's Apache Polaris-based, so it supports the Iceberg REST, so I can go talk to all the other Iceberg tools in the ecosystem. And basically, several features that allow us to be sort of the fastest on Apache Iceberg. That's why we refer to ourselves as an Apache Iceberg native lakehouse, because it's Iceberg first, not Iceberg second. Then there's the agentic AI platform piece, where basically we have all the tools you need sort of baked into the product, so that way you can take advantage of agentic AI on your unified data from day one, including a AI semantic layer, which is made up of wikis, tags, SQL views, a knowledge graph, all these things that kind of help build context around your data, so that way AI can answer questions better and faster, okay, which saves you money and saves you time. You also can take all that functionality that our AI agent has built in, because we have that built-in AI agent. You can bring it to your AI agent using our MCP server. We have AI SQL functions. And then we have a new CLI that is basically sort of AI native, in the sense that it's built not necessarily for you to use a CLI, but for your AI agent to use a CLI to interact with Dremio. So we have all this tooling around AI that you can now use across your unified governed data. That's the Dremio story. And you can just try this all out for free. If you don't believe me, go to dremio.com/get started, try it out, and see it for yourself. No cost, no credit card, no infrastructure. You just get to play with it for 30 days for free. Here's another sort of nice little cartoon. I'll leave this up there for a few seconds. It's just me telling you the same story that I just told you. Bottom line, if you want to try out the Dremio platform, head over to dremio.com/get started. And my name is Alex Merced. I'm the head of DevRel at Dremio. So not only am I the creator of the Data Lakehouse Hub community, but I'm also the head of DevRel at Dremio. I've gotten to write a lot of books, many books like Apache Iceberg and Apache Polaris, the definitive guide. and leveraging federation, the semantic layer in the Lakehouse, which you see over here. I did not write Agentic AI for Dummies. That's my European counterpart, Will Martin. So make sure you follow both of us on LinkedIn if you don't already. But you can find all 4 of these books and download them for free by scanning the QR code you see on the screen. So I'll leave that up there for a moment so anyone who wants to download those books can. Okay, cool. So now that we've kind of gotten through now back to our regularly scheduled programming as it gets the words that I'm looking for. And bottom line is basically Iceberg is all about modular evolution again. In every version, we want to kind of make things better. Okay. And then V4 is about just trying to sort of better. A lot of it is about just trying to improve on the metadata handling of Apache Iceberg by identifying the bottlenecks and fixing them, and generally in two different ways. One, how quickly can you traverse and access and leverage the metadata in Apache Iceberg and do it in a performant way? And then 2, how fast can you write it? Okay, so how fast can you, so better organized metadata is going to allow you to traverse that metadata faster, but also how can you commit and write that metadata faster, and different ways that just kind of help reduce the bottlenecks of the traditional way that Iceberg works, where all metadata has to be committed to a storage system before it can really be leveraged. So bottom line, there's essentially a bunch of different proposals. In this case, 8. There's a lot of proposals in V4, but this is really focusing sort of on, this presentation is focusing on sort of 2 paths that a lot of these proposals are going under. One, making the data smarter. Again, this is things like the adaptive metadata tree that's focusing on compact encoding. So again, basically being able to store more metadata in less space, more intelligently, making it faster to traverse, so faster on the read side, and making the metadata lighter. Okay, this allows the rest, basically by offloading a lot more work to the catalog using the REST catalog standard, so that way not everything has to be done through files in the file storage, which will allow a lot of aspects of like caching, or also just like using other type of mechanisms to store metadata other than just the files themselves, and basically offloading a lot of the metadata bloat onto the catalog, who can decide how to best handle that metadata bloat, whether they want to store that data in some other format or in a database or wherever they'd like. So you can kind of see like the dependency across all of these proposals kind of over here. Okay, this includes things again like the way we're handling stats, so aggregate column stats. We'll talk about that in a second. The compact bitmap format, which is essentially just trying to make deletion vectors even more efficient. Oops, back in the wrong direction. Okay, partition tuples. Again, basically, I'll talk more about that in an upcoming slide. But again, all under the one file commits umbrella. The metadata.json scalability, because again, metadata.json becomes bigger and bigger as you have more snapshots. So the question is like, how can we still retain our snapshots without having to have metadata.json bloat? So this is where we're going to offload a lot of these snapshots possibly to the catalog. Okay, and maybe even just make it optional altogether. Now, tags in V4 are basically just adding another way for you to sort of mark things for like governance and things like that. So making data smarter. That's again that first stream. So the idea here is just trying to sit there and say, hey, how much can we do within one file? So that way you're not having to write all these different manifests, these different manifest lists, these different metadata JSON, all these different files that kind of add up. So the idea is just saying, taking that core metadata file and making it contain most of the things. Okay, one part is like the column stats. So one is just turning the statistics into something that's more consistently definable via schema, because then you can actually move the data into like Parquet files. That might be more efficient. Compact bitmaps, which will allow you to store things like deletion vectors in a more compact way and make that even more efficient. Partition tuples, basically saying, you know what, how about we move partition stats with the rest of the content stats? Because right now, if you've ever looked at Iceberg metadata, the partition stats for a particular manifest are a separate thing than all the other stats for that file, which are generally like a current, like a binary blob that just is referred to, and then you have to kind of go in there and parse the binary blob and do things like that. So, and it's on that specifically, the blob part, where we're really kind of getting a lot of work done. Okay, right now, again, basically there's a column stats field in the DevRel files that contain your manifest, where it's just essentially a binary blob that's essentially key value pairs, basically details about your column stats. Now, if you can actually turn that into a typed field, okay, that's going to make it much easier to traverse that data much more efficiently. So again, that's going to now allow you to have richer metadata, faster queries, because again, it's much faster to traverse data that you know how it's shaped than basically having to kind of take this unknown blob of data and having to go traverse it and figure out how you're going to traverse it at the time. Again, there's the whole detail of basically creating smarter deletion vectors. So deletion vectors are sort of binary blobs that track sort of, hey, which files and which records and which files should be ignored. Okay. So by using bitmaps, you can just kind of basically have an on and off switch for lots of things. And then depending on how you structure that bitmap, it's going to take up a lot less or more space. So right now in V3, these deletion vectors live in Puffin files. But now there's discussions about putting them in bitmaps that would live inside the Parquet footers. So that way, basically, you would not have to go read a separate file and then go to the Parquet file. If the Parquet file is part of the table at the time, which records you would need to ignore would be in those footers as a bitmap, and you can just access it there at that time. So basically, if you don't need to read a file that has a deletion, one of these bitmaps, then you just don't need to read the bitmap at all. So you're only reading the bitmaps that are sort of relevant to your particular query. Now back to the partition stats. Again, it'd be nice to have all the statistics in sort of one place. So essentially, if we turn that blob of stats and turns that into this typed thing, could we add the partition values there too? And then you can easily pull them out. There's some debate over this because there are some edge cases where basically putting those partition stats in with the column stats, or just like the stats that would in that blob can trigger some edge cases. But again, ideally that would just be more organized or cleaner, where there's just a stats area. Okay. Now that's all. So every proposal I was just talking about now are for in the sort of cleaner metadata. So the idea is just making the metadata easier to traverse, which means better read. But at the end of the day, we don't just optimize for read, we optimize for write, okay? Which means, hey, we want to be able to write to that metadata faster and have to write less metadata, so that way we can commit the transaction faster, which means we can query the metadata, query the effects of that transaction sooner. So the idea is to move from metadata.json possibly to moving more towards a catalog being where a lot of this hot top-level metadata exists. Okay, really the catalog acting as more of that granular metastore. So in this case, it could still persist them as files. It could, hold them in memory. It could save them in a database. It could be an unstructured. It could be a NoSQL database. It could be a SQL database. Like there's lots of options to how the catalog decides to then persist that metadata. That change has to happen in the REST catalog because right now, like the REST catalog endpoints require you to send back like not the metadata, but the location of the metadata. So you're kind of bound to using persisted files. But if instead the REST catalog could just return you the metadata, then where that metadata physically exists becomes less important. That becomes sort of an implementation decision on part of the catalog creator. So wait, skipping slides there. Okay. So basically, in solving metadata.json, first they were thinking about like multi-file sharding. It looks like this has been sort of rejected just because it's overly complicated. Basically splitting up the metadata.json into multiple files. Generally, the idea here is to have less files. And then also just basically the approach they are going is making it optional. Just saying, hey, you just don't need a metadata.json. The catalog can just save the information, and now the catalog can just grab the info it needs. It doesn't need to grab every snapshot. It doesn't have to deliver you a list of every snapshot every time. It can just grab the info for the snapshot that's relevant for you, send that over. In this case, it just doesn't have to give you all the metadata every time. So currently in V3, which is the current standard, you would have these big JSON files. And again, the more snapshots you have, the bigger the JSON file, and you have to download the whole JSON file before you can read it. And again, those snapshot histories would have every commit. Now, theoretically in V4, what's going to happen is that you won't have to download the JSON file. You can just contact the REST catalog and say, hey, I'm just looking to query this particular snapshot or this particular table, and it can just send you directly to the snapshot that you need and not have to give you the entire history of snapshots and any other information that is sort of superfluous to the query, which, again, makes it faster to read, but also faster to commit because you're not rewriting this entire JSON file and the entire history every single time you do a transaction. Okay, so you have to write less files, which means you can commit the transaction faster. Now, not every proposal survives. There are proposals that have been rejected. Okay. But some other things to keep in mind are things like tags. So basically, the idea here is to place these are security tags. These are things that you might use for like tag-based access control or policies for other types of behaviors that would be communicated. So the idea is just to be able to load sort of these essentially metadata that were built in the table. Okay. Bottom line is before they were kind of in the schema right path, and that's not necessarily ideal. So the idea is again, move it more over to the REST catalog. So like the tagging and the awareness of these sorts of tags will exist in the REST catalog. So again, how does the REST catalog actually track these things? Becomes an implementation detail. From the client side, they would just request what they need from the catalog, and the catalog will get it to them. And different catalogs can figure out the way they want to do it. Okay. Delta encoded schemas. Okay, the pitch. Replace full schema snapshots with the base schemas plus deltas to solve wide table metadata explosion. The pushback is the problem on disk size or just payload size. Consensus argues for trying simpler mitigations first. So basically, the idea is like, hey, you're trying to solve a problem, but you're introducing a lot of complexity to solve something that might be able to be solved through something simpler. So again, not every proposal gets accepted. Oh, we're just moving stuff around a lot. There we go. Let's doot. Okay. The bottom line is when we take a look at sort of the state of v4, because things that we see advancing, again, I think like the constant stats and bitmaps, basically smarter deletion vectors, better stat handling so that we can have more traversable stats to read that metadata faster. Things that it looks like everyone's kind of finding consensus on and should probably maybe finalize sooner than later is the optional metadata JSON. Again, moving a lot of that over to the REST catalog and letting the catalog be the abstraction that handles sort of the implementation details for how you store that metadata. Things that are being debated are like partition tuples, okay, and things that have been sort of like redirected, rejected, or like tags and delta schemas. Moving those over, still a lot of discussion going on there. But I'll leave you off with sort of 3 golden rules when it comes to governing sort of like the shaping of the v4 proposals. Bottom line is, again, the cloud first rule. You want to solve scalability at the catalog rest boundary before touching on the structure. So the idea is basically let the catalog try to abstract away so that way you're having to touch object storage as little as possible, because the less round trips you have to go make to object storage, money you save, time you save. The unification rule, collapse multiple concepts into general mechanisms. Idea is that instead of introducing sort of all these new different APIs into the Iceberg spec, can we have more things fall into sort of more generic interfaces, so that way those interfaces can handle many things instead of a lot of very specific interfaces. The uniformity rule, keep semantics strictly uniform, reject awkward special cases. Basically, the idea is everything should sort of follow the way that people expect things to be done, and instead of introducing, again, new APIs or basically creating little exceptions in those APIs where, hey, for this one use case, you do something slightly differently, try to figure out how to keep it within the realms of what's expected and what's standard currently. And those generally are going to be the kind of proposals that meet those rules that are going to have the most success in finding their way into v4. Now, the road ahead, okay, there's generally architectural things that go on within the Iceberg community. You can follow the Iceberg mailing list to find out when these are. And there's going to be some to resolve the partition debate, things to sort of, clean up a lot of this discussions regarding discussing metadata cleanup. And that's, again, just really helping, like, one, make the implementations and solidify the format for v4. So that wraps up this presentation. Hopefully you guys enjoyed it. Again, this is the first Data Lakehouse and an AI lunch. I hope that you'll join us in future iterations of this. Again, you can head over to datalakehousehub.com to find the list of these. Do join either the Slack community for Data Lakehouse Hub or join the Dremio developer community at developer.dremio.com. Either place, you can message me if you're interested in joining one of these sessions, speaking at one of these sessions in the future. Okay, we're generally going to have room for like 2 to 3 15-minute talks. And yeah, we'll have a lot of fun. I'll see you all later. Have a great day and enjoy.